Alright, we're continuing our march through chapter 12, talking about 12-2 circles. This is the first day of circles. This is more just an introduction. Part of the reason I'm doing chapter 12, and this in particular, is that this often will show up on the ACT. You'll get a random equation. If you recognize it as the equation for a circle, life is good. You can do the question. If not, you're just kind of scratching your head, wondering what in the world's going on. So a circle, if you go back to geometry days, definition of a circle was all the points in a plane. Otherwise you get a sphere if it's not limited to two-dimensional objects. So all the points in a plane, a given distance from a point. And if we were to kind of unpack that a little bit, that a given distance, that's just going to be the radius of the circle. And the point is going to be the center of the circle. Now our book has two equations. Push comes to shove, just learn one. Just learn the second equation, and then you can use that equation for any circle. But if you're good at memorizing equations, go for both. By now you probably have an index card from me in class. You could go and print out the one that has everything from Moodle, but probably decent just to write your own. Take about the same amount of time. But first thing, if you have a circle that's centered at the origin, the equation is simply going to be x squared plus y squared equals r squared. So x squared plus y squared equals r squared. If you're only going to memorize one, don't let it be that one, because we could take our equation for any circle and kind of simplify it down to that. So the equation for any circle, if you remember back to when we were talking about lines, so I wouldn't write this necessarily, but we started out talking about lines. We had y equals kx. I'm just going to write y equals mx. And y equals mx plus b, so this is kind of like a plus 0. That was a line through the origin. And we said, well, we could take and move that around. We changed it to y minus y1 equals m, x minus x1. And now we go from a line that's through the origin to a line that's through some point x1, y1. We did that in chapter 3. Chapter 6, we were talking about parabolas. We had y equals ax squared, a parabola centered at the origin, so its vertex is at 0, 0. And then we said, well, we could take and move that. So y minus k equals a, then an x minus h, quantity squared. Need the squared to make it so it's a parabola still. Now instead of it being centered at 0, 0, it was centered at hk. So this one here, maybe I'll write centered at 0, 0. This one here, we know it went through 0, 0. This one here, we know it goes through x1, comma y1. Well, now we're going to take kind of a third lap. We do that same exact thing with a circle. That for a circle centered at the origin, we just have a nice x and y. Now if we have a circle that we want to move the center, well, it's going to be, instead of just x squared, we're going to take h away from x, which if you look is the exact same as what we did right there with the parabolas. So x minus h, quantity squared, is going to give me how far it moves left or right, that's my h value, plus y minus k, quantity squared, that's going to be how much is moved up or down, equals r squared. So this would be the equation I'd learn. And I also had mentioned that it's centered at, or the center of the circle then is going to be the point h, comma k. Just like in chapter 6 when we were talking about parabolas, the vertex of the parabola was hk. Alright, so I want to come up with an equation here that we can go through and find the center of the radius and graph it. So I'm going to go with this one. So given x minus 3, quantity squared, plus y plus 5, quantity squared, equals 9. So that's an equation for a circle. If you see something like that on the ACT, you can be like, and it'll look familiar, and you can go from there. Well, if we're going to try to find the center, at least until you get really good, please, 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 go through like I've been trying to get you to do all year, write out your equation. And two advantages of doing that. One, if you do that, you're a lot more likely to get the question right now, get it correct now. And the other thing is going to be when I ask you to know it from memory on the test, you'll know it because you've written it out several times. But the center then, the center of my circle, is going to be h comma k. So to find those, you just line up your parts. So h is going to be a positive 3 because it's x minus the x value. And just like with our parabolas or with our lines, the x value is going to be the number that's with the x, and the sign will always be switched. When it's a minus 3, it's really a positive 3. Here we have y plus 5, so 5 is going to have something to do with our y value, but it's y minus the k. So when you have a y plus 5, you could view that as y minus a negative 5. Just remember the sign is always switched. Y plus 5 is a negative 5. Alright, my radius then has to be 3 because r squared is 9, so square root both of those and you get r equals 3. And we have our center, we have our radius. To graph it, you could spend a lot of time trying to get everything perfect, but this is how I'd encourage you to do it for my class at least. My center is over 3 down 5, so I could put a little dot there at 3, negative 5. Now my radius is 3. 3 up is going to be easy to do. You just count up 3. 3 to the right, same thing, easy. 3 down, easy. 3 to the left, easy. Now if you're trying to go like diagonally, you could spend a decent amount of time trying to do that. I'm okay with you just getting kind of these 4, hesitate to call them corners, but the 4 points that are easy to get. Then from there make something that looks like a circle. And hopefully yours will look better than mine. Using my little smart tablet thing is tough to get something that looks nice, but use your pencil. You could always go back and erase, but something like that would be good. And try to get rid of my little bubble there. Something like that. So for circles, make sure you have your sides, your top and bottom accurate. Then in the middle, make it look like you put some time into it. All right, example 2. Write an equation for a circle centered at negative 2, 9 with a radius of 7. And because that's not at the origin, we go with the equation x minus h, quantity squared, plus y minus k, quantity squared, equals my radius squared. And now we just need to fill in my h and my k and my r. So you could go through and say, alright, my equation is going to be x minus the x value of my center. So my x value is a negative 2, so instead of x minus a negative 2, which isn't simplified, minus a negative is the same as just adding 2. So x plus 2, quantity squared, plus y minus my y value, so y minus 9, quantity squared, equals my radius squared, so equals 49. So once you get an equation in that form, please don't FOIL and try to combine everything and move the 49. That's a totally legitimate equation for a circle. And I thought that was it. That's all the notes from section 2.